Good morning. My name is Sangeeta BL, working as an assistant professor in Department of Electronics and Communication in Vivekananda College of Engineering and Technology, Puttur. Today we'll be studying about the experiment that is pulse amplitude modulation. We already know what is an amplitude modulation. So it is nothing but varying the amplitude of the message signal with respect to the carrier signal. So same as in case of pulse amplitude modulation, so it is nothing but you are varying the train of pulses with respect to the amplitude of the signal, which is nothing but the message signal, is varied with respect to the train of the pulses, which is nothing but the pulse amplitude modulation. So as you know, this pulse amplitude modulation is considered as an analog modulation scheme. So if we study the circuit now, so you can see there are two transistors used, which has nothing but VCET transistors, and there are two signals which are used. One is modulated signal, that is your message signal. Other one is the pulses which we use, that is nothing but your square signal. So initially take the amplitude of the message signal, either 1 volt or 2 volt peak to peak, as well as the carrier pulses, which is of 5 volt amplitude. And the frequency of this message signal should be in between 300 to 500 kilohertz, as well as the carrier frequency should be 8 kilohertz or 5 to 8 kilohertz. So when you set up the circuit initially, leaving this carrier signal, that is your square signal, connect the 1 kilo ohm resistor directly to ground and check whether across the output you are getting a square signal, modulated signal, that is your sinusoidal signal. If that is the case, if you are getting this modulated signal or a sinusoidal signal across this output, then you can proceed by giving your carrier signal. So this circuit you can now initially, when you give a signal to this 1 kilo ohm, so across the transistor you are taking the output. So the output across which you get across the transistor is an inverted one. So this observation of a pulse amplitude modulation we can see in the CR. So initially what you have to do is take the modulating signal. So that is, I have set it to 1 volt peak to peak. So after this, take a carrier signal. So you can change this probe and give it to the carrier signal. Take a carrier signal now, which is nothing but pulse. Give it as 5 volt peak to peak. So I will set it to reduce the amplitude. Keep this for 5 volt peak to peak or 5 volt. So this is the square signal. So after setting this, and frequency also you should note. So the frequency of the message signal should be around 300 to 500 kilohertz. So it is, I have kept it around 635 kilohertz, and the frequency of the carrier signal should be around 5 to 8. So it is around 6.25 kilohertz. So now what you do is, in order to measure the output, check across the modulating signal. So remove this double-ended probe from this, give it to message signal. This is for the carrier signal. This is for your modulating signal. So now we can observe the output across channel 2. So first set the amplitude of this. Is 1 volt peak to peak. It is 5 volt, peak it to 1 volt. Reduce the amplitude. This is 1. You can see the output now. So now it is not the proper output, adjusted by varying the frequency. So you can see the output of a pulse amplitude modulation. So whenever you get such distortion in the output, reduce the amplitude, make the signal proper. So vary the frequency in order to stop the signal, as well as the frequency of your carrier signal. So you can vary from 5 to it is 7 point, again vary this. So how you measure your output is proper is check whether the output which you are getting is an inverted output. If it is not inverted, then it is not proper. So now you can see you are getting an inverted output here. For negative of your modulating signal, you are getting a positive peak. You can vary the frequency in order to see the proper output. You can adjust either by varying the amplitude or the frequency. This is your pulse amplitude modulation output. So what you have to do is, the readings which you have to take here is, one is the maximum point, other one is the minimum point. So if I take the maximum point, so put it to ground first, bring it to the midpoint. So now you can measure from this line to this line, will give you the maximum point. So it is 1, 2, 2.4 and 2. So Vmax will be 2.4 into the channel 2, that is 2, which will give you 4.8. And we have to measure what is the minimum point. So bring it to the minimum position. So it is around 1.3. So 1.3 into 2 will give you 2.68. So this is the maximum amplitude of your pulse amplitude modulation. So around this, from here to here you are getting 4.8. So this 4.8 which you are taking as Vmax, actually this is nothing but, or I will show you in the graph. So this is the amplitude I have taken it as, now it is 2 volt, I have taken it as 1 volt peak to peak. So this I have kept it to 5 volt, that is your pulse train. So the output across you get from here to here, it should be a maximum amplitude of 5 volt which you are giving for your train of pulses. So now I have got the maximum point at 4.8, that means it is almost equal to your 5 volt amplitude. The same thing if you take from here to here, that is your modulating signal, minimum point to here, so that it should give you around what is the amplitude of this. So this is 2 volt peak to peak, so which around we are getting around 2.6 or 2.2. So this is the modulation of a pulse amplitude signal or a pulse amplitude modulation. So this is a part of modulation. So now we'll check what is the demodulation. So the simple circuit which we use for demodulation is, you have a 5 kilo ohm resistor in parallel with your DCB, that is decayed resistance box, that is a variable capacitance. So give the modulated output to a resistor, other one to the a resistor pin. So you can take the output across the DCB. So in order to measure what is the value of capacitance, you have a formula, that is F cutoff is equal to 1 by 2 by RC, where we are taking the resistor value as 5 kilo ohm. The frequency which we are choosing for a carrier frequency, that is 3.3 kilohertz. So we can check whether we are getting a demodulated signal by connecting a resistor. So this is the decayed resistance box. So there is a 5 kilo ohm which is connected to this pin, to this, and this should be given to ground. So if you vary the frequency, even your demodulated signal will vary. So when you plot the graph, so just plot it below this. same as your modulated signal. So draw the graph for the demodulated signal, but the amplitude which you take here, it will be less than 1 volt. So here when you take the modulation, you will take the amplitude as 1 volt peak to peak, whereas when you get the demodulated output, the output will be less than 1 volt. So this is nothing but the demodulation as well as modulation part of your pulse amplitude. Thank you.